Welcome to the test review for graphing trig and inverses. We're going to do the first part of just graphing tangent and cotangent. There'll be another video for the second part of this unit, inverses, their graphs, and evaluating. So let's get going. Here we go. The first problem that we have gives us four different equations of tangent and cotangent and asks for us to find the graph that matches it. So I'm going to start with just looking at b, y equals tangent of x. It has boundaries at negative pi over 2 and positive pi over 2. The middle point is at x equaling 0 on the midline of 0. It'll curve up to the right at pi over 4 and down to the left at negative pi over 4. And then C, cotangent, looks similar, but it has different boundaries. Its boundaries are at 0 and pi, so its middle point will be at pi over 2, 0. It'll go down to the right at 3 pi over 4 and up to the left at pi over 4. So cotangent and cotangent are reciprocal functions, so you basically take tangent and flip it upside down, although it does have a different domain. Okay, so we can look at those. And then the first example, what I'm noticing is that it's a negative tangent. So if I want to do a negative tangent, I'm going to look at B and I'm just going to flip it upside down. And then this one will have a midline at -1. Okay, it does have a shift to the left, pi over 2 units, so that's going to change its domain values and those boundaries. And then our example D is a negative cotangent. So a negative cotangent, so look at my cotangent, which goes down to the right, so this one will go up to the right. It will have a midline at +2, and it is going to shift to the right pi units. So that means the boundaries instead of 0 to pi are going to be from pi to 2 pi. Okay, so let's look at our graphs and see if we can figure out which is which. I like to start first with the midline and then look at the shape. So the first graph on the far left does have a midline at 0, so that means it's either tangent or cotangent. And then if I check the boundaries, this guy is graphed, has a full cycle between negative pi over 2 and positive pi over 2. So that's definitely our tangent function. It also follows that same pattern that we just briefly discussed. Okay, the second graph, it looks like the midline for this one is actually down here at -1. So by the shape of it, it would have to either be cotangent or a negative tangent. Because of the midline, it's definitely got to be the negative cotangent function. The other thing is its boundaries are from negative pi to 0 or from 0 to pi. So that represents that shift to the left that we see in the parentheses. All right, our third graph. Let's see, looks like the midline on this guy is 0, so that clearly tells me just by midline purposes, it's got to be the cotangent function. Check its boundaries, 0 to pi, and it takes that shape. That is perfect. And by process of elimination, our last equation, negative cotangent of x minus pi plus 2, has to be the last example. And it does have a midline at 2. It is shifted to the right pi units, so the boundaries are from pi to 2 pi. And it is a negative cotangent graph. Great job. Let's continue on. All right, what is the range of 5 cotangent of x minus 2? Okay, guys, think about the pictures we just looked at. Every single tangent and cotangent took the shape of like those cubic functions, kind of looks like that. And they have a domain, or excuse me, a range of -infinity to +infinity. True for all tangent and cotangent. All right, cool. All right, state the transformations from the original cotangent function to y equals -5 cotangent of x minus pi plus 3. That -5 in the front is going to reflect the midline and give us a vertical stretch. The shift that we have in parentheses is going to take us to the right pi units. And the shift at the back end, that's our midline, going to go up 3. Number 7, what's the period of the function? Y equals negative tangent of 2x plus pi minus 1. Remember, we always look at that b value to determine our period, which is pi over b. In this case, pi over 2. Cool. Moving along, here we go. Number 8, What is the phase shift of the function y equals 1/2 tangent of x plus pi over 3 plus 4? Okay, we haven't said a whole lot of phase shift stuff for a while. We just talk about the left boundary. What's the left boundary? That's all it means. It's taking the horizontal stretch or shrink, this one does not have, along with its shift horizontally left or right, and putting those together to get that left boundary. So we're going to set everything in parentheses x plus pi over 3 equal to negative pi over 2. That's where that asymptote would be, that left boundary where it's undefined. And then we will solve by subtracting pi over 3 and simplifying. So x equals negative 5 pi over 6, which means our phase shift goes left pi over 6 units. Great. And then our last two before we get to the graphs, let's see, cotangent, where is it undefined? In other words, what are its boundaries? 0 and pi. Now, you can have other boundaries. Your graph can be shifted, so it's actually just going to go by pi units. So 0 to pi, pi to 2 pi, 2 pi to 3 pi, and so forth. Or you can go in reverse order as well. And then the values where tangent is undefined are going to be at negative pi over 2 and positive pi over 2. Again, those are the boundaries we use to graph the function, which we're doing in the next 4 examples. Here we go. Graphing tangent for numbers 11 and 12, and then cotangent for 13 and 14. So when we're graphing our tangent function, we need to get the amplitude. That just means the a value in the front, which is 2. And then we need to get the midline, which is y equals 0. I don't have anything added on to the back end. So that means I can draw my midline on the x-axis. And then to get the period, you'll notice I've rewritten this example. We have tangent, 2 tangent of x over 4. That is the same thing as 1/4 times x. Remember, it's like 1x divided by 4. So you can separate that out as 1/4 multiplied by x. Therefore, our b value is 1/4. Pi over b is the period. When we simplify that, we will get a period of 4 pi. It is 4 times as long. We have a horizontal stretch or elongation by a factor of 4. Okay. Our increment takes the period and divides it by 4, so we're going to count by pi for the increment. Now let's get our boundaries. Set x over 4, or 1/4 x, equal to negative pi over 2 for the left boundary. Multiply by 4 on both sides of the equation and solve to get the left boundary to be negative 2 pi. Your right boundary can be found by adding the left boundary and the period, or set x over 4, oops, there's a little typo here, guys, x over 4 equal to positive pi over 2, multiply both sides by 4 and get 2 pi for the right boundary. So my graph already has all of these increments listed. You guys can choose, since we're counting by pi, and I'm going from negative 2 pi to positive 2 pi, that would be negative 2 pi, negative pi, 0 pi, 2 pi. Those are going to be my x values. And you can count by 1 space or 2 spaces for every pi units. Mine just has it as showing all the pi over 4 units across. Alrighty, so we need asymptotes at the boundaries at the negative pi over 2 and positive pi over 2. My middle point goes on the midline, actually at the origin, 0, 0. We'll use our amplitude to go right pi and up 2 from the midline. And we'll use it to go left pi and down 2 from the midline. And then we will connect our points with that cubic curve, getting the shape of our tangent function. Great job. We got 3 more. We might go a smidge over the 15 minutes, so just stick with me. Here we go. Number 12 is y equals negative 2 tangent of x plus 2. So we have a couple transformations. That amplitude is 2, but it does have a reflection, so it's going to flip its direction from the previous example. Our midline is at 2, so sketch your horizontal line at y equaling 2. And then we don't have a horizontal shift or vertical stretch or shrink, so the period is just pi. Pi over 1 is pi. Meaning our increment we're going to count by is pi over 4, and then we can get our boundaries. Set x equal to negative pi over 2 and x equal to positive pi over 2, which there's nothing to do for these, so those are just the boundaries. So we need to count by pi over 4s in order to get to our beginning and ending places. Remember, we can convert negative pi over 2 to be negative 2 pi over 4 and pi over 2 to be positive 2 pi over 4. So you can just count by pi over 4s on your graph and go negative 2 pi over 4, negative pi over 4, 0, pi over 4, and pi over 2. At the left and right boundaries, we will get the asymptotes. We'll put our middle point on the midline, so it'll be at the point 0, 2. And this is a negative tangent, so when I go to the right pi over 4, I need to drop down 2 from the midline. When I go to the left, negative pi over 4, I have to go up 2 from the midline. And then we will sketch our graph. Remember, this time the left side is going to curve up and the right side is going to curve down because it's a negative tangent function. Let's try cotangent. Number 13 is y equals cotangent of 2x minus pi minus 1. Okay, it does have a horizontal shrink of a half, so the period should be half the length. It's going to the right and it's also going down 1. The amplitude is just 1, no changes for that one. The midline again is at y equals negative 1, so sketch that line. The length of the period is pi over 2. It's half its regular length. So this is a horizontal shrink or compression of 1/2. Okay, that means when we take the period and divide it by 4 for the increment, we'll get pi over 8. So I want to count every space as a pi over 8, or every other space as a pi over 8, whichever spacing you like. The boundaries for cotangent are 0 and pi. So we're going to take 2x minus pi, set it equal to 0, add pi to both sides, and then divide by 2. So our left boundary is at positive pi over 2. Okay? And then our right boundary, set 2x minus pi equal to pi. We will add pi to get 2 pi and then divide to get our right boundary at pi. So our boundaries are from pi over 2 to positive pi. And again, you can change these. Pi over 2 is equivalent to 4 pi over 8, and pi is equivalent to 8 pi over 8. So I want to count by pi over 8 as I go through my x-axis to get my points. So I'm going to start at 4 pi over 8, then I'll have 5 pi over 8, 6 pi over 8, 7 pi over 8, and then 8 pi over 8. Okay? And you'll see I had to kind of tuck those up and down in there so they would all squeeze into our graph. So our boundaries and our asymptotes occur at the pi over 2 and at pi. Our middle point on the midline is 6 pi over 8, which is 3 pi over 4, and we're going to go down to the negative 1. Then this is cotangent. So cotangent, the right side goes down, the left side goes up. So I'll go over to 7 pi over 8, go down 1, and then over to 5 pi over 8 and go up 1. So again, left side up for cotangent, right side down for cotangent. All right, we're getting there. We might make it within the 15 minutes. Yay us. Last example, y equals negative 3 cotangent of x plus pi. The 3 gives us the amplitude. It's a vertical stretch. The negative tells us to reflect our graph. So our negative cotangent actually looks like a positive tangent. The midline for this example is at 0. Y equals 0. Our period does not change because we only have a coefficient of 1 in front of our x. So the period is pi, making the increments pi over 4. Okay, we are now going to determine the boundaries, set x plus pi equal to 0 for the left. To get negative pi for the left boundary, set x plus pi equal to pi for the right to get our right boundary of 0, which means everything's going to be to the left of our y-axis, or at the origin 0, 0. So I can count backwards by pi over 4. So 0, negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, and then negative 4 pi over 4. Here we go. So I'll have negative pi, negative 3 pi over 4, negative pi over 2, negative pi over 4, and 0. We will have the asymptotes on our boundaries. at negative pi and 0, midline point at negative pi over 2, 0. And then because it's a negative cotangent, when I go to the right at negative pi over 4, I'll go up 3. When I go to the left at negative 5 pi over 4, I'll go down 3. Connect your points with that curve that looks like our cubic shape, and we are done. Great job, guys. The second part will be uploaded along with this one, so come back for part 2.